Okay, log video number 1. We're going to start with some really basic refresher. We're going to go all the way back to the beginning of it, and it'll go by pretty quickly, but I just want to put it all here for you so that if you're writing this down, you'll have it all in one place going forward. This is all the foundation. Everything builds off of this. If you don't have this, then you can't learn much else. So to begin with, the basic properties of logarithms is we say that for all x greater than 0 and all a greater than 0 such that a is not equal to 1, y is going to be equal to log base a of x if and only if. That's what that means. If and only if. If and only if x is equal to a raised to y. And that's just the property that you've already established. You've seen that. You know that this is just asking to what power must I raise a to obtain x. That number is y. Therefore, this is the exact same question, just worded differently. It's the inverse. And by that, so just to write it down and have it in one spot, by that token, this statement y equals log base a of x is logically equivalent to the statement x equals a raised to y. And just to show that, because I'm really glad that you pointed it out, that this is the inverse of this, taking a log of something is the inverse of doing the exponential function, you can see that. And you know how to compute logs now, and you know how to square numbers, obviously, so you can graph this, and you can actually see that they are inverses. So if we put, it'll look like this. I'm not actually going to plot points, but let's say that we have the line going along the center that's just y equals x. And then we have some function, say f of x equals 2 to the x, and then another function, g of x, log base 2 of x. Now you know that these are just asking the same thing, but in the opposite direction. So 2 of x is going to look something like that. 2 to the x is going to look something like that. Log base 2 of x is going to look like this. If you graph them, if you do it, I guarantee you, that is what you will get, because they are mirror reflections about the axis. So you can actually see that they are inverses. And now, just some more simple little properties. And then we'll do some simple little examples of these just to reinforce it. I want it quick in your head. I want you to be quick at identifying these little things so that it'll make solving bigger problems easier later on. First property states that log base a of 1 equals 0, and you can see why. It's pretty self-explanatory. You can't get back to 1 exponentially unless you're raising any a to 0. Second property, log base a of a is going to equal 1, obviously, because you don't get back to a exponentially unless you're raising it to 1. And you were hitting on this a little bit. When we were first learning this, you kind of discovered that an exponential function looks like this, where you've got, say you have 2 to the third, or whatever. So this just tells you how many times the number is going to appear in this sequence of multiplications. And In this case, obviously, you'd like that number to just be 1. So you only get left with 2. The third property states that log base A of A to the x is equal to x. And this is something that you can see. I mean, you know that log base A of A to the x is equal to x times log A of A, which by property 2 we know equals 1. Alright, so this is just x. And conversely, A raised to log base A of x is also equal to x. In general, whenever you see this form appear in an equation, I want you to just instantly cross this part out, because it's gone. Like if you see A raised to log base A of anything, where the base is the same as where the bases are the same, just cross it out and bring the x down. Just bring it down. The fourth and final property is called the one-to-one property. It's a simple one. It just states that log, well, hang on. Getting ahead of myself here. If log base A of x equals log base A of y, so if the bases are the same, then x equals y. Makes sense, right? If the bases are the same, then that should be true. And in fact it is. And we're going to test out some examples right now. Just some quick little ones to get your little footsies wet. And so I'm going to write all these problems down, and I encourage you to pause the video and just try to solve them yourself. It shouldn't take you longer than a few seconds. They're quick. But then I'll write out the answers, obviously. So initially, we've got log base 4 of 1, log root 7 of root 7, 6 raised to log base 6 of 20, log 7 of 7 raised to 8, log base pi of pi, because why not? You might see that. 9, that's not a 9. 9 raised to log base 9 of 15. And finally, last and least, log base 1.5 of 1. So go ahead, if you haven't already written them out, write them out, solve them, just write the answers.